Hello everyone, today I'm going to share my learnings about Ian Stewart, Nature of Numbers, Chapter 4, The Constant of Change. In 1997, Ian Stewart published his book called Nature's Numbers, and in that book, we got a glimpse of how mathematician views our natural world. There are many chapters in the book Ian Stewart, but today, I will focus mainly on Chapter 4 entitled The Constant of Change. But do you know the context of this book? If not, then it is your chance to listen. Today, I'm going to share my learnings in this topic. Long ago, humans thought that nature swung between two opposing points of view. One view believes that universe obeys fixed immutable laws and everything is well defined. Objective reality, while the other believes that there is no such thing as objective reality and that everything is flux in all change. As we discover the truth and the knowledge about the people who greatly contribute to this ideology, lend at your ears and open your imagination for us to travel back in time. The rise of science is largely being governed by the first viewpoints, but as we advance together as a society, there have been increasing signs that prevailing cultural background is starting to switch the second way of thinking. In this presentation, I will share my learnings about the constant of this reality and how they generate, change, and alter the findings of the class. I am Shena May Anino, BSN 1B. Now, I'm going to dive deep into the constant of change. Now, we begin as we take a step back into the Renaissance with the discoveries of Sir Isaac Newton. Isaac Newton, when we hear his name, what is the first thing that comes into mind? Is it gravity? The apple falling to make well both guesses are correct. However, did you know who Isaac Newton is? Isaac Newton was an English mathematician, physicist, astronomer, theologian, and an author who was famous for his laws of motion and the law of gravitation. He and his friend Gottfried Wilhelm Leibniz invented calculus and its two techniques, the integration, differentiation. Both techniques work side by side or in one and thus the other. Between them, they tell you that if you know any of the functions, the position, velocity, or acceleration, at every instant, then you can work out the other two. Using the law of physics, the change in nature can be described by mathematical processes. For example, the heat equation is described as the rate of change in a body's temperature. But what is rate of change? A rate of change is about the difference between some quantity now and its value an instant into the future. Equations of these kinds are called differential equations. To learn about Newton's discoveries, aren't we all amazing how the earth magically flows in space? Gravity, in fact, is what holds our world together, and it's not magical force. Over 3 centuries ago, gravity was discovered. The solution of striving, it was the basis for Newton's discovery of the law of gravitation. Assumed that all bodies in the universe must be attracted by the same force. The mathematical formula for motion was solved back then. Some examples include Ohm's law, law of friction, and Joule's law. Newton and his successors were unable to find exact solution for a system of 3 or more bodies. Rather, they attempt to devise methods for calculating approximate numbers around 1860. For example, the French astronomer Charles Delaunay filled an entire book with a single approximation to the motion of the moon. A simple example of an approximation algorithm is the minimum vertex cover problem. Si-Hong Sia demonstrated in 1994 that a system of three bodies is not integrable. He demonstrated that such a system can exhibit a strange phenomenon known as Arnold diffusion, which was first discovered by Vladimir Arnold. Arnold diffusion produces an extremely slow, random drift in the relative orbital positions. This drift is not truly random. It is an example of what is now known as chaos, which is defined as seemingly random behavior with purely deterministic causes. Lorentz attractor and double pendulum are both chaotic behavior examples. It's worth noting that this approach alters the definition of solve. The word originally meant to find a formula, then it shifted to find approximate numbers. Lastly, it has changed to tell me what the solutions look like. In some ways, what is going on appears to be a retreat, but it is incorrect to interpret this development as a retreat because this change in meaning has told us that there are no formulas for questions like three-body problem. Mathematics might deal with the scientific derivation of formulas. Its qualitative approach in the method explicitly advances the field. Therefore, the concept of change stems from the philosophical aspect of the scholars to pursue whatever they aspire to acquire in the body of knowledge. To sum up, the concept of change proves that numbers are not static but rather dynamic. It is always to change, open to change. The book of Ian's The Word Nature in Numbers is fascinating, especially the chosen topic, the constant of change. I realized that this chapter deals with the pollution of a strict law and flexible flux in nature. I learned a lot from it. Math, it allows us to recognize patterns, quantify relationships, and forecast the future. We use the word to understand math, and math helps us understand the world.